Now we talk about the AC voltage applied to an inductor, topic number 7.4, which is represented here. Now see, this is the AC source which is applied. Okay, AC source is having this symbol. Okay, it's positive and negative alternately changes. Okay, and this is the inductor, okay, which is joined with this source. Now if we apply Kirchhoff's rule, first of all, this voltage which is applied is always, we have V is equal to Vm sin omega t. This we have to keep in mind for the whole chapter, that voltage applied is V is equal to Vm sin omega t. And if you apply now Kirchhoff rule, then if you go from, say for example, any instant, this is negative, this is positive, then this becomes positive and this becomes negative. Now if you go like this, and from negative to positive it becomes plus V, and then with the current, if you are moving in this direction, then the voltage drop, as you know, L di by dt across the inductor that we have studied in the last chapter, and with the current, so negative is equal to 0. So this becomes V minus L di by dt, where this is nothing but self-inductance or self-induced electromotive force. If you make V as a subject of formula, then you will get V is equal to L di by dt. Now this is very easy mathematics. Di by dt is made subject of formula, so it becomes V upon L here. Okay, and instead of V, we are writing Vm sin omega t. So this di by dt will become Vm sin omega t upon L. So if you make di as a subject of formula, this di, okay, then it becomes Vm sin omega t dt into, see here there must be Vm sin omega t dt divided by L. So this t is missing here, that you just write. Okay, so it must be di is equal to Vm sin omega t dt upon L. So this is very clear, very easy mathematics. Okay, now here this di, if you want to integrate, okay, here L is the self inductance. Okay, this is our equation number 1. Okay, which indicates that current, that is I of t, current at any time t, as a function of time, it depends on time, as time changes, because it is sin omega t. So at time changes, the value of sine function changes and current changes. Okay, so I of t as a function of time must be such that its slope is di by dt. Okay, it is sinusoidally varying with the same phase as the source voltage, which is having the amplitude Vm upon L. So the current is having the amplitude Vm upon L. Okay, now just we integrate. If you do not write this thing in your answer, then it will do. You just have to mention that the amplitude of the current is Vm upon L and taking integration of this equation number 1. Okay, so what will you get? You just integrate on both the sides. Okay, integration sign is placed. Sin omega t dt is the function whose integration we have to take. Now integration of sin omega t will become minus cos omega t. Multiple of t is omega, so we have to divide by omega, so it is minus cos omega t upon omega, so it is written here with negative sign, plus some constant of integration is written. Okay, so this is very clear. Now constant of integration is time independent and it is found to be 0, because at t is equal to 0, okay, if you write instead of t here you take 0, then that current I will be equal to 0, so that constant will be equal to 0, so that constant will have value to be 0. So our equation, that is I is equal to, what is that? I is equal to minus Vm cos omega t upon omega L it will become. This is the equation of current. This is the equation of current. Now that cos omega t, try to understand. Cos omega t is having minus sign. Minus sign is taken with cos omega t. So minus cos omega t can be represented as sin omega t minus pi by 2, because as you know that the function, that is cos function, is negative in the second quadrant. Okay, or we can say, try to understand this way also. See, if you have say minus cos omega t, okay, then we can write this as sine pi by 2 plus theta. Try to understand. If you make this sine function, what you call it, this cos function is negative in the second quadrant and minus in the second quadrant, so minus cos of omega t, try to understand, can be represented as, first of all, cos function if you want to represent in sine, then how would you represent? It will become sine of pi by 2 minus omega t. Pi by 2 minus omega t. Now this cos function is represented in sine. This minus sign is already there. Okay. So minus cos omega t is minus sine pi by 2 minus omega t, and if you take sine of minus theta, if you take this minus sign common, then that sine of minus theta, as you know, this is minus sine theta. Okay, so or you take this minus side inside, whatever you want to understand you can understand. So minus cos omega t is equal to sine of omega t minus pi by 2 it becomes. Okay, so it is converted into that sine function. Okay, so here cos of, rather it is minus cos of, this minus cos omega t is converted into sine omega t minus pi by 2, because cos omega t is sine of, cos omega t is nothing but sine of pi by 2 minus omega t, and if you have minus cos omega t, then this becomes minus sine pi by 2 minus omega t, and if you take this minus inside, then what will become? It becomes sine of omega t minus pi by 2. So this way it is written here. Okay, Vm upon omega L is kept as it is. This Vm upon omega L is taken as Im. Okay, Vm upon omega L is taken as Im. So this equation of current becomes I is equal to Im sine omega t minus pi by 2. So this is a different equation. See, equation of the current is different. How? By, say, voltage is given by Vm sine omega t, and here current is given by I is equal to Im sine omega t. Both are having sine function, but there is a phase difference of pi by 2. You can see here it is sine omega t, where here it is omega t minus pi by 2. So this current is having the phase 90 degree less than the voltage, we can say, and here this value which is taken here as omega L. Okay, this omega L is named as inductive reactance. There it was Vm upon R. Try to understand in the resistor. Here it is omega L. In its omega L is called the inductive reactance, which is denoted by XL. So XL is equal to omega L, and its unit is ohm. Okay, the inductive reactance limits the current in the purely inductive circuit in the same way as the resistance limits the current in purely resistive circuit. So both are having the same function. Okay, now our equations of current and voltage are here. Okay, V is equal to Vm sin omega t is the equation of voltage. I is equal to Im sin omega t minus pi by 2 is the equation of electric current. Okay, so here current is lagging behind. See, current is having its phase 90 degree less than the angle of this voltage. So current is lagging behind the voltage by pi by 2, or we can say it is 1/4 cycle behind. Okay, now see the phasors are drawn. See, it's very easy to draw. First of all, you just have to draw this horizontal and vertical axis. Okay, first of all, voltage is Vm sin omega t. So at any time t1, if you want to draw, then you draw the length of voltage as Vm. This angle must be omega t1. Now another phasor, that of current, that is 90 degree behind. So this is whatever is this, the phasor makes an angle at 90 degree behind. Just you have to draw, this is perpendicular to voltage, and this is the phasor of electric current, which is 90 degree behind. So this angle will be 90 degree. Okay, that you can see here. Okay, and if you want to draw the current, then for current the voltage is having sine curve, so you just have to draw the sine curve. Okay, you just have to draw the sine curve for voltage. Okay, so at any time t1, this will be the value of the voltage. This is for voltage. Okay, now see the other one, that is current, is having its phase 90 degree behind. So just we have to draw it from 1/4, that is slightly below. So the sine function will start from here, and phase difference is of 90 degrees. So from here it should pass like this. Okay, so it is drawn like this. Okay, so the phase difference is 90 degree. Okay, whenever the voltage is maximum, then current is 0. Okay, here you can see the voltage is 0, then the current is maximum. This way there is a phase difference of 90 degree between them. Okay, so try to draw this 2-3 times so you can understand. Okay, now the current phasor I is pi by 2 behind the voltage phasor, that is V, or we can say it lags. Okay, so pi by 2 is nothing but t by 4. Okay, so pi by 2 is equal to t upon 2 pi multiply and divide. Okay, so pi by 2 divide by omega it becomes. Okay, so it becomes the value to be pi upon 2 omega. Okay, the value of this time will be pi upon 2 omega. Okay, because if you convert it into the angular frequency, okay, then this can be easily understood. Here you can see that 2 pi upon t, as you know, 2 pi upon t is nothing but omega. So here this t upon 2 pi is taken as 1 upon omega. Okay, so it has been written in this way, that it is 1 upon omega into 2 pi by 4. So it will become pi by 2 upon omega, or we can say pi upon 2 omega. So this in terms of angular frequency can be pi upon 2 omega. Okay, when rotated with frequency omega counterclockwise, that is anti-clockwise, they generate the voltage and current given by this equation. My equation of voltage and current is V is equal to Vm sin omega t, and for current it is I is equal to Im sin omega t minus pi by 2, as shown in this figure. Okay, now we talk about the power in this circuit. that is containing inductor, and as you know, power is equal to I into V, and I is nothing but, as you know, that it is Im sin omega t minus pi by 2, and it is Vm sin omega t. So just it is taken as Im Vm cos omega t into sin omega t, because as you know, sine of omega t minus pi by 2 can be written as minus sine of pi by 2 minus omega t, and sine of pi by 2 minus omega t is nothing but cos omega t, so it can be written as minus cos omega t. So instead of this sine omega t minus pi by 2, it is written as minus cos omega t. Okay, so it is again a mathematics. Okay, see, cos omega t into sine omega t, it becomes, okay, now just we have to multiply and divide by 2. So what will happen? Minus Im Vm into 2 sine omega t cos omega t divided by 2. So 2 sine omega t cos omega t will become sine 2 omega t. So this becomes minus Im Vm by 2 sine of 2 omega t. So this equation we are getting. Now if you find the average, now as I have explained that average of sine theta over entire period is always 0. So we just find the average power on a complete cycle, then we just show by this bracket Im Vm by 2 is constant, minus sign is also taken out, we can take, okay, and the average of sine to omega t is 0, so this will be rather equal to 0. So average of sine 2 omega t over complete cycle is 0, so average power supplied to an inductor over a one complete cycle is always 0. Okay, so this is very easy to understand. Okay, okay, thank you very much. Try to understand it 2-3 times. Okay.